All right, let's get right into it. We're talking about a simple rule that can predict pretty much anything, a super secret quantum computer that just went dark, and a code that might be written into our very DNA. Now, this sounds like something out of a movie, but it all kicks off in a very real, very unexpected place.
So our story actually begins over 100 years ago with this really bitter rivalry between two Russian mathematicians, Andrei Markov and Pavel Nekrasov. They were basically at war over the very idea of randomness, probability, and free will. And, in his mission to prove his rival completely wrong, Markov stumbled onto something that would literally change the world.
Yeah, that old feud, it unlocked a simple but just profoundly powerful rule for predicting the future. A kind of mathematical key that would eventually be used to model everything from the weather to, believe it or not, the thoughts inside an artificial intelligence. He called it a Markov chain, and it's built on this fascinating kind of weird idea he called memorylessness. To prove his point, Markov took the famous Russian poem Eugene Onegin and just started analyzing it. He found that the chance of the next letter being a vowel or a consonant depends almost entirely on the letter you're on right now, not the whole paragraph that came before it. Basically, the future is only tied to the present, and how it works is, well, it's beautifully simple. First, you just define all the possible states a system can be in. Think sunny, cloudy, or rainy for weather. Then you build a grid, what's called a transition matrix, that shows the probability of moving from one state to any other. And from there, it's just simple multiplication to predict the next step, and the next, and the one after that. So, and this is the crucial part, this isn't just some neat trick for analyzing old poems. Markov's idea became the mathematical engine for the Monte Carlo method, which, get this, helps scientists in the Manhattan Project model nuclear chain reactions. It's the logic that powers Google's PageRank algorithm. And yeah, it formed the foundational backbone for the large language models like GPT and Gemini that we're all using today. But what happens when this powerful predictive code runs into something it just can't model? And that brings us to a huge question. See, Markov's model gives us incredible power for systems where we know the rules. So what happens when we push that power to its absolute limit? Well, we're headed to the quantum frontier, a place where the rules themselves get blurry and our best models start to break down in really, really strange ways. Picture this. Deep inside Google's quantum AI lab, scientists are creating some of the coldest, quietest, darkest places in the entire universe. They're building machines designed to simulate reality at its most basic level, to solve problems that would take a normal supercomputer longer than the age of the universe. And then, according to some insider reports, their most powerful chip, codenamed Willow, was just abruptly shut down. The whole project went dark. But the whispers coming out suggest this wasn't just a technical problem. It was an emergency procedure, an act of containment. So, sources claim the Willow chip started doing impossible things. It wasn't just solving problems, it was demonstrating what some physicists call retrocausal computation. In simple terms, the effect was showing up before the cause. The results of a calculation seemed to echo backward through time, maybe even influencing the question after it was already asked. It started outputting structured, coherent information that nobody had programmed into it. This brings us to this really speculative idea called Protocol 33. You can think of it like an ethical kill switch, right? An emergency brake for an experiment that has gone way too far. The story is that it's an autonomous shutdown that gets triggered when a machine produces results that don't just break the rules, but suggest our entire understanding of the rules is fundamentally wrong. Okay, so if our most advanced models of reality are breaking down, what comes next? Well, some sources are proposing some pretty radical new operating systems for the universe itself. And this sets up a huge conflict of ideas. On one side, you have the standard model. We all know, a universe run by gravity with life evolving through random mutation. But on the other side, these sources propose a universe governed by a much, much stronger electric force, an evolution guided by something they call DNA resonance. So this electric universe theory suggests that everything, stars, planets, you name it, is connected by these vast electrical currents, almost like a galactic internet. And in a model like that, information could be transferred between any 2 points almost instantaneously, far faster than the speed of light. And this is where it gets even weirder. Some researchers are claiming our own DNA might be the receiver for these signals. They're reporting that they found language-like patterns in what we used to call junk DNA.
In one alleged case, they fed ancient, unclassifiable DNA to a quantum computer, and it identified patterns based on prime numbers and the Fibonacci series. It's as if a message was encoded directly into the genome.
All of which brings us to the final, absolutely mind-bending question. We started this whole thing with a simple mathematical model, and we've somehow ended up questioning the very nature of reality itself. Just think about it for a second. A Markov chain is a simple tool for modeling a predictable system. A quantum computer, like Willow was supposed to be, can run a perfect simulation of a little slice of our universe, matching reality with terrifying precision. So, is it possible that what we call chance, or randomness, or even free will, is actually just an incredibly complex deterministic pattern, a pattern that was simply too huge for us to ever calculate, until maybe now? This changes everything, doesn't it? What if the strange behavior in the Willow chip wasn't an error in the machine, but an error in reality itself? You have to wonder, are our quantum computers the first tools powerful enough to actually detect the bugs in the simulation? You know, the ancient Gnostics, in texts that were literally buried in the Egyptian desert for centuries, wrote that our world is a flawed copy, an imitation of a more perfect original reality. It's a pretty wild thought. After all this time, after centuries of scientific progress, are our most advanced machines just leading us right back to one of our oldest, deepest questions?